In this video we're going to look at how to use the sine rule to find the missing lengths in triangles. So we can use the sine rule when we are using two sides and the two opposite angles in some way. So in this first example I've got a length of 4 centimeters opposite an angle of 35 degrees and an angle of 40 degrees opposite a length A centimeters. So this is a prime example of where the sine rule can be used, and the sine rule says that a length divided by the sine of the opposite angle is going to be equivalent for each pair of sides and angles in the triangle. So 4 over sine 35 is equal to A divided by sine 40. So to find the value of A, I can then solve this equation. So I'm going to multiply both sides by sine 40. So A is equal to 4 sine 40 divided by sine 35. And this is something I can evaluate on the calculator. So I don't know if you can see, but on the top of my calculator there is a D in the top of the screen in the middle, and this shows me that I've got it in degrees mode, which is important because later on in C2 you're going to come across a way of measuring angles which is not in degrees. So I'm just going to type this straight into the calculator as it looks. So I've got here 4 sine 40 divided by sine of 35. Okay, I can evaluate that and I get an answer there, so 4.82663,993. May be a good idea to give this to 3 significant figures, so I'm going to write it as 4.48 centimeters. If you're not sure, then just write it out to more decimal places and simplify it afterwards as the second step, and then you cover all your bases really. So this second question, I've got 9 centimeters and I've got the angle opposite. I've got 25 degrees, I don't have the length opposite, and I've got a length here and I don't have the angle opposite. But I can still use the sine rule because you should know that one of the properties of a triangle is that the angles add up to 180 degrees. So if I know 2 of the angles, then I can work out this missing angle up here, which in this case must be 105 degrees. So now I can set it up as before, so I can say that 9 over sine of 50 is equal to A over sine of 105, and then I can multiply through by sine 105, so I can have 9 sine 105 over sine 50, and that is for A. And then again I can evaluate that on my calculator, so I've got here 9 sine 105 over sine of 50, and that gives me 11.348. so I'm going to again give that to 3 significant figures, so in this case that will be 11.3 centimeters.